Hello, everyone. Welcome to the stream where we'll be learning and actually we'll be building up AI powered adaptive web scrapers by using large language model. Well, these both terminologies are really hot nowadays. Um, Web scrapers, artificial intelligence, and we have included large language models in it as well. So yeah, that's going to be very interesting. And by the end of the session, we will have something really built up, something really interesting. I'll give you a teaser as well in the beginning in a minute. Um, a short introduction about me. My name is Zia. I have been working in domain of data. When I say data, it means data mining, data scraping, data analysis, data science, and much more. So I've been working in this industry for over 7 years now. Currently, I'm working with Google as a data scientist, but I have been working as a data mining engineer, a web scraper, and many more related fields that are related to data. I have done a master's in data science actually. So anything that is related to data, where talking to data is necessary or important, that's my area of interest and the field of expertise. So yeah, we are gonna solve mainly two problems in today's stream. Two very important problems that are being faced by the web scrapers, those who write code or use any technique for web scraping. These two are the main problems that they really face. First, and the primary problem that we are going to solve in this stream is website update breaks when when we have a scraper already written. I mean, we have a pre-written scraper that is working great. That is scraping up data, desired data from the website, but suddenly it breaks down. And 99% of the times, the reason is structure of the data. If they update structure of the data, structure of the website at the back end, our scraper will not work anymore. Let me give you an example. And for the sake of example, we'll be following Zillow.com website. And this is a property real estate based website. So let's search any, oh yeah, I've already searched California. So let's search homes in California and see what we got. So we've got some homes over here. So if I go to inspect this page, I'll get the whole source code of this page, right? Now, if I particularly go to the address of any particular property, I can see I can access it by multiple ways, by any class, by any ID, or any HTML related reference. So for example, here we access it by class, and this is the class name that we can use, right? And our scraper will be working great over here. But after 1 month, 2 months, 2 weeks, 10 weeks, or whatever, or maybe a year, they change the structure of the website in a way that these class names will be replaced by some other class names. So our scraper will not work anymore. That's a problem. So we'll see how AI can help us today in order to solve this problem. So let's say we have a scraping code, a scraping script that is working great, but the website structure got changed, and now our scraper is not working anymore. So we'll see how we can use large language model. Well, large language model is quite a scary term. So let me give you a softer term. So we'll use ChatGPT, or we will use Gemini, or any other model that is acting as breakthrough. Well, you can use DeepSeek as well, to repair that scraper, to repair that script that has been broken, right? So how these large language models can help us out over there. And second problem is related to scaling. So let's say if you're not professionally working as you're not professionally scraping the data, you're just scraping the data for fun. So you need to hit a website or a URL for maybe 1 time, 2 time, 10, 20 time. That's fine, great. But if you are doing it for some commercial purpose, then scaling it up can be a problem, because if you'll be hitting a URL several times, they might block you. They might block your IP. So how to deal with that problem? We'll come to the solution of second problem in a minute. Actually, a bit more than a minute. So let's come to the first problem. By the end of this session, what we will be able to achieve? We'll be learning about the essentials of web scraping, how it actually works, not going into depth, but overall high level idea, so that we can have a base to talk about the basics of AI. So if you do not have any idea of AI, I'm not going to go into mathematical terminologies of AI. Don't worry about it. I'll be explaining AI in roughly 5 to 10 minutes in a way that everyone will be able to understand it. And then we'll see how AI, at number 3, we'll see how AI can help us building adaptive web scrapers, right? That is our primary goal for this session. And then we'll see what is the role of large language models in web scraping. We'll be utilizing the capabilities of ChatGPT specifically. Well, if you have paid account for ChatGPT, that's great. But if you don't have it, well, it will work perfectly fine as well, because the um, the scraper or the whole workflow that we have built will work perfectly fine, although in a limited manners, but it will work perfectly fine with the free accounts as well. So let's go to our end goal, what we will be able to develop after this 1 hour session or 1 hour stream. Where is our code? Okay, so first of all, we'll be able to scrap the data, or we'll be able to create such a pipeline. Even if the website structure got changed, we can detect that change, and later on we can repair our structure without going into code. Obviously, we'll use the code, same code, but this time LLMs will be will be helping us out. So let's say we'll be scraping the property price, number of bedrooms, number of bathrooms, area, and address from Zillow. Okay, so we have property price available over here, number of beds, number of bathrooms, area, and the address is also available, right? So we'll be scrapping all this information. Then let me scroll it up. Then we'll be cleaning up the data. Since you can see this information, it has a bit of junk values. For example, the dollar sign, the comma sign. Well, it is not junk for a common man, but for a data scientist, for a data analyst, when you'll be statistically working with the data has to be in numerical format, right? So in order to convert this data into a numerical format, we'll be doing something that I'll be explaining, and then we'll be having the data in numerical format. Once we have data in numerical format, we can perform tons of different operations on it. For example, we can perform different kind of visualizations over here like this. I'll be explaining all this. And the interesting thing, we will be building a machine learning algorithm that will be actually predicting, given number of bedrooms, number of bathrooms, and the area, it will be predicting the price of that property. Now imagine you have a localized artificial intelligence model that will be able to predict prices. For example, you have an AI model that is trained on the data which is available in US, let's say the California-based data. But you want to make predictions on the Middle Eastern data, for example, on Dubai properties that are in Dubai. That will not work fine at all, because there are many changes. I mean, I don't want to go into depth, but there are many changes. There are many factors that are changed between California to Dubai. So what will you do? You have to provide more data related to Dubai in order to create an artificial intelligence model that is specialized in Dubai property price prediction. So here, we'll be creating a whole pipeline where all you have to do is you have to just search the name of the city over here on Zillow. For example, we are specifically talking about US right now, and we'll be able to create a localized on a state level, a localized artificial intelligence model by just running these few lines of codes. Okay. So I hope we are interested in it. So let's get started. So what is web scraping in just 1 or 2 minutes? We go to any website and we need this data. There are two ways to get the data. Either we have someone who will be entering this data manually, which is a dumb way, and it will take a lot of time, a lot of money. And we are living in 21st century. We don't want to do that. The second way is we can play around with this source code which is available, because the whole data that is available over here on the website, it is also available in the source code. So all you have to do is you have to get the source code, or you have to hit the URL that will give you the source code, and you have to scrape the data from here. You have to mine the data from here, and you can get your desired data. For example, if I need price, number of bedrooms, and blah, blah, blah from here, I can scrap this desired data. If I need these pictures as well, we can get that as well. A bit tricky, but yeah, we can get that as well. We can deal with pagination and all the other stuff as well. Now, the thing is, again, I'm reiterating the problem. If this website structure gets changed, I, as a human being that has the real intelligence, human has the real intelligence. You know why artificial intelligence is called artificial intelligence? It is not real intelligence because it is inspired from human intelligence. So I, as a real intelligent person, allow me to say this, please, right? So I, as a real intelligent person, I can detect fine. Yeah, here is some change in the website structure, in the HTML structure. So I'll take care of this change. I'll rewrite the code, and it will work perfectly fine. But what if you're not a very techy person, or if these changes are very frequent, or you want to, make this cycle very autonomous? So how to do that? In order to do that, we can make use of artificial intelligence. If you don't want to, make your real intelligence very busy, you can make use of artificial intelligence. So before we make use of artificial intelligence, first of all, we need to learn how AI actually works. And as I promised, I'm going to explain how AI work in 5 to 10 minutes. Don't worry about it. Very easy, in very easy terminologies. So get ready. Okay. So I will be explaining how AI works, or how AI learns, by an example. It is just like how kids actually work, how kids actually learn. So let's say you have a tiny kid at home, and you want this kid to recognize, to classify how uh, you want this kid to recognize, or you want this kid to distinguish between cats and dogs. Okay, so what will you do? You will go to probably zoo, or maybe in a park where there are cats and dogs, right? So you'll say, hey, look, kid, that's a cat. Okay, fine. Kid will say, fine. Okay, this is a cat. So anything with four legs and a tail is going to be cat. Fine, I got it. So kid will train its neurons, its brain cells, in a way that whenever I'll see something that has one, two, three, four legs and a tail, I'm going to call it a cat. Okay, fine, that makes sense. Next day, when kid goes to zoo again, or maybe to the park again, the kid will say, hey, dad, looks, that's a cat. He will say, no, that's not a cat. That's a dog. Well, kid will say, okay, so anything with four legs and a tail is not going to be cat. Maybe the height or size actually matters. So anything with four legs and a tail and the size is shorter, going to be the cat. Exceptions are there. And anything with four legs and a tail, but height is a bit bigger, then it's going to be dog. Again, edge cases are there. There are dogs that can look like cat in certain cases, because they're small in size. So I'm on a bigger level. I'm speaking on, and on a bigger picture. I'm speaking over here, right? Okay, fine. Now you keep going to public places or zoo, and you keep feeding more and more data of cats and dogs to your kid, and your kid will keep learning more and more features about these two animals in its mind. And with the passage of time, with a passage of more and more data being fed to kids mind, uh, kid will be able to master classification between cats and dogs. And there will be a time when maybe kid will be telling you, hey, look, that's a dog, that's a cat. So now let's say training is done. Now you want to test your kid. Fine. If this kid has been trained well enough in order to classify between cat and dog or not. So what will you do? Maybe you will take your kid to some new place where uh, this kid hasn't been before. And you will say, hey, now, kid, tell me, what is this? Remember, before you were telling me this is dog. So you were labeling the object with its title, with its label. Okay. Now you are expecting this kid to tell you the label. You will say, hey, tell me, what is this? What is that? Perhaps kid will say dog or a cat. Maybe you will ask 5 to 10 different questions about these two animals. And then at the end of the day, you will see, okay, fine. The accuracy of this kid recognizing cats and dogs is great, because out of 5, it has recognized 5 correct, five correct animals. Or maybe you say, no, its training is not going well, because out of 10, it has only recognized 5 animals correctly. So maybe if the training is not well enough, if you think a kid is still not able to recognize correctly, you will feed more and more data. Maybe you will start showing more and more pictures of these animals. Maybe you'll start showing more and more these kind of animals. And ultimately, when you'll think again while testing your kid, you will think my kid is classifying or recognizing these animals perfectly fine. Then yeah, you can say now training is done. Well, why am I telling you this story? Because the training of this kid and training of an artificial intelligence agent is exactly same. How AI works. We have to feed a lot of data to AI so that this AI will train its neurons according to the data, and it will learn. We will also provide the labels in some cases that, hey, look, for example, this is an email which is spam email, and this is an email which is not a spam. It is a ham email or a correct email. We have this filter all the time in Gmail, Outlook, whatever email engine we are using, right? How it actually works. Because on the back end, the models have been trained, the AI agents have been trained with a lot of data, with a lot of similar data. Like these are the tons of spam emails. Maybe in spam emails, it will be written like 20% discount, 50% discount, get something for free, these kind of words. And these are the real emails where it will be written like, hey, we have a meeting tomorrow, something like that. So the model will be, the AI agent will be grasping the data, grasping the features from this data. And then later on, when you want to see if this model is working fine or not, what will you do? What have you done with that kid? You will take this model to some new data that hasn't fed before, and you will give a new email to this AI agent, and you will ask this agent, hey, tell me if it is ham or spam. Ham means non-spam email. According to the learning, AI model will tell you if it is ham email or spam email. If this classification is going great, then you will say, hey, yeah, this model is working fine. I don't have to train it more. But if this classification is not correct, then we have to train our model again, maybe again, and for n number of times until we don't get our desired results. So the stages in any AI algorithm, we have to gather the data, then we have to prepare the data, we have to train the model, and finally we have to test the model as well. And once testing is finalized, once testing is done, we can deploy this model as well. So next time, whenever you have this question in mind, whether AI can do this or that, how would AI be able to do that? How AI was trained over this thing, or that task? Just think it like how you have trained your kid for any particular task. The resemblance is quite much similar. As I mentioned, AI is artificial intelligence, and kid has the real intelligence, right? So now we want to see how AI can help us build adaptive web scrapers. Again, I have already explained the problem 2 times. The problem is we already have a scraping code that is working great, but now it is broken because website structure has been changed. So how AI or large language model, which is the probably in my opinion, I can be wrong. In my opinion, that is the greatest wonder of AI so far, like ChatGPT or Gemini or DeepSeek. How these models, how these agents can help us out in fixing that code, and we can again scrape the data. Okay, that part will come later. But right now, I want to hypothetically speak about how we can create a pipeline where AI will be automatically fixing these kind of issues. So, for example, again coming back to the problem, um, this is a class name. Scrapper works fine. The class name gets changed. Scrapper will not work fine. So, first of all, we need to detect if the scrapper is working fine or not. If it is working fine, let it work fine. If it is not working fine, then there should be an artificial intelligence model that can fix it. Now, in back of your mind, think how this artificial intelligence model will fix this scrapper. How will it fix? The tagline is, if you don't know, ask yourself how you will fix it. Okay, fine, I know there is some change in this class name, so I will fix it. How would you know? Because you have trained yourself on tons of data, because you have been working as a web scraper, as a data mining expert for a long time. You have seen a lot of these kind of pages, HTML pages, where you've seen, okay, fine, previously this class name looked like that, now it is looking like this. This is the change, so I will adjust my code accordingly. So here you need data. Just like the kid needed data related to dogs and cats. But your problem or our problem is related to web scraping, is related to web pages, source code of the web pages. So we have to feed a lot of HTML pages before and after. So we'll say, hey, AI, this was the before page, and this is the after page. Okay. And we will also annotate, for example, particularly here in this class name, it has got changed. And if this got changed, previously, this was my code. Now this is my code. Okay. That was my code and this is my code. And these are the changes. We will label those changes. Labeling those changes is called data annotation. So we have to feed tons of data, tons of such data where we can train an algorithm just like we train a kid. And there will be a time when this training will be done in repetitive manners. It will be done good enough that AI agents will be able to automatically detect that, okay, fine, this was the previous structure, this is the new structure. Now these changes should be made in the code. Seems quite appealing, right? But seems quite difficult as well. You have to have a lot of data, a lot of HTML pages in before and after manners. You have to have a lot of codes that are working in before and after manners. And then you need high expertise or you need experts. So overall, and obviously you need very good machines with GPUs that are expensive. So overall, it is a very much time consuming process and it will take a lot of money. I will suggest not to try it at home. If you really want to try it, at least try it at a commercial level where you have great budgets and great teams. Well, that's a bit demoralizing. If we cannot do it at home, then why are we attending this stream? Well, we have a workaround that we introduced in the beginning that is called LLM, large language model. So we'll be using ChatGPT. ChatGPT is already a trained AI, a trained large language model that can work on different problems. You can ask ChatGPT to write a song for you. You can ask ChatGPT to write a recipe for you. You can ask ChatGPT to write a code for you. You can ask ChatGPT to fix a code for you as well. That's what we are going to do. Well, is it going to work every time? Is the kid going to recognize dog and cat every time? Well, yeah, if the kid will be wise enough or old enough, then yes. But right now, AI is not wise enough, not neither old enough. So maybe it will not be working perfectly fine for 100% times. But yeah, we can say that it will be working fine for 90 to 95% times. It also depends upon the instructions, which kind of or which type of or which format of prompts we are feeding it, right? So let's go. A lot of talking is done. So let's go into the work. What do we want to do? Yeah, first of all, we need to simulate changes as well. So what I've done is right click over here, click on this save as. So you will be able to download this page in HTML format. So I have already downloaded it. Where is it? So yeah, so I have two files. This is the original file, right? And this says updated. So what is the updated thing in both of these files? I'll come to this in a minute. First of all, let's go to our coding environment. Let me bring this original file to the coding environment. How can I do that? I want to upload it. Since I'm working in a desktop mode where my taskbar is not available, so that's why I need to minimize this page. Yeah, so I can drag this file over here, and let me go through this code very quickly, right? So I have imported beautiful soup over here, which is used for data mining, pandas for data analysis. So I'm simply going to open this HTML page that we downloaded from here. Okay, the data might look different because on the timestamp when I'm trying it or when you're trying it, so it might look different. And then we are saying soup, which is a variable, from beautiful soup, get all the content, HTML content from this file. Okay, and then properties is simply a list where we'll be appending all the properties. For each list element, we are getting all the divs with this class. Okay. If we go back, if I show this whole card, you see all the divs have this card. All the divs have the class which is equals to this. Okay. So I'm getting all the divs or divisions that have this class over here, right? And then I'm saying for listing and all the list elements which are getting from here. So in this loop, in each iteration, each card will be iterated. Each card means each property will be iterated. Since from each property I have to get the price, I have to get the number of bedrooms and all the details. So I'll be iterating over each property, each card one by one. What next? So here inside this loop, as a listing variable, we will have each property. From that each property, we need to get, I think, 4 things or 5 things. We need to get the price. So price is available in the spam that has this class. If we want to verify this, we can click over here. You see this is a span and it has a class that says property card wrapper, blah, blah, blah. And we have the same over here. Yeah, property card wrapper and blah, blah, blah. This blah, blah, blah is really important. Just kidding. Okay, so then we are simply saying strip the text so that it has no left and right spaces over there. And then we are saying if we have the price, then do it, then write it. But if we don't get the price, then write NA over here, not available or not applicable over here. Why are we going to do that? So that if the class name gets changed later on and Scrapper is not going to work at all, then the code should not break. It should just write NA over there so that we come to know, okay, fine, here is the problem. Okay, so we will get the price like that. We'll get what else? We'll get all the bedroom details like that, since bedroom, bathroom, and area details are available as a list, unordered list. So we'll get unordered list, and then from that unordered list, we'll get all the list elements. First of all, we will have bedroom, right? Since on the zeros index, we have bedroom, number of bedrooms. Then we have the number of bathrooms at first index, and so on and so forth. We also have the area of the property as well. Address is listed a bit differently, not differently, but separately. So if we go to the address, it has a separate division, and then it has an anchor sign, anchor tag, sorry, a tag, and then it also has a class. We have copied and pasted the same class over there in the code. We are going to play around with this class a little bit. We will change the name of this class and we'll see which kind of behavior we'll receive from the code. Okay. So if I run it, let me make sure the file name is written correctly. Yeah, file name is correct. So yeah, I am able to scrap the properties, the price, number of bedrooms, bathrooms, area, and the address. So I've got it. Now, if I go back and I use this updated file, I drag the same file over here, and the name of both files is same. Just in the updated file, I have appended updated over there. So I'll write updated. Now I'm going to work with this file, this updated file. What is the difference between these two files? I'll come to it in a minute. I'll show you. If I run it, the same code, but the file is different now. If I run this code, I'm getting price, bedroom, bathroom, area correctly, but the address is not available. Why? Because when it tries to fetch the address is not available over there. It executes this part of the code, which means the address is not available, which means something fishy is going on over there, which means this class name is not correct right now, since we have updated file. So yeah, in updated file, I have changed the class name over here. Okay, so let me go to our code editor and let's get this class name first so that we can search it. So this is the original file. So if I search class name over here, so yeah, here we have the class name, and it is exactly same. So if I get the count, I have 41 matches over here. But if we go to the updated file, as you see, this is the updated file, and if I try to search the same thing over here, I check the count is again 41, but with slight bit of difference. If I scroll right over here, you can see this updated appended over there. Now the class name is not exactly same. I have appended or added this thing dash updated over here. Now if you allow me to search for this class name in the original file, well, what happened? Come on, buddy. Don't try to play around. Okay, so let me get this, get this. No, not all. Come on. Actually, I am using um, this Windows after a long time. I've been using Mac, so it's playing around with me. So we have this updated class name from the updated file. Let's search it in the original one, and you will see we'll not be able to find it. Find next. No. Count 0. 0 match. So our previous code was written according to this file, Zillow file. But now our file is updated one, where the class name has got changed everywhere. It has 41 appearances and it is changed at 41 places, right? Now, if we come to the code, we can also see that this code is not working fine over here. So we have to do something for it. Okay, so what will we do? We'll go to ChatGPT, and I already have written a prompt over here. Yeah. Okay. So first of all, we have to define our role, right? This is a good practice in order to write a good effective prompt. You have to define your role first. So I'm saying, hey, I am scraping a real estate website from Zillow, and I'm using Python. But my old code or my old scraper is not working anymore. I'm explaining my problem here. So what I want you to do, I will provide you some scraping number of bedrooms, bathrooms, price, and area, and all these things. What I will do, I'll give you two files. This is the original file. This file contains old website structure that I have in HTML format, and this file contains the new website structure. Your task is to analyze both structures, and here is my old code. Now these three things that we already have. Fourth thing is the label that we want, is the prediction that we want. I want you to write the updated Python code according to the new structure of the website, right? So I'll copy this. I'll come over here. I'll remove the initial lines that are not necessary. Now we need to get our files over here. So get them here. And oh, what happened? It says I'm unable to. Okay, let's get them like this and this. Let's see if it will work. Yeah, it is working. And then let's close this. Okay, and then here we have the code part. So we have to paste the old code over here. This is the old code. Yeah. Okay, so let's write then. Let's change this file name of the file to the previous file name. Copy this, select all, copy this, and paste it over here. Okay. Meanwhile, our HTML files are also uploaded, sorry, and let's run it. Now, all we have to do is we have to wait for just a few years so that ChatGPT, no, not a year, just a few seconds, so that ChatGPT can respond to us. Again, meanwhile, since ChatGPT or any large language model, it is not always advised to use ChatGPT. Other large language models are also doing great. It is not a promotion video. So you can use any large language model that are working fine in the market. So what actually did these large language models do? These large language models are actually multi-purpose models. Multi-purpose model. They have been trained on tons of different data sets that are very diversified. They're trained on coding data sets. They're trained on analysis data set. They're trained on recipes data set. So they're multi-purpose artificial intelligence model. So we can ask them to write code. We can ask them to fix code. Right now, we are requesting them to fix the code. So let's see if it works or not. So I think execution is done. So yeah, it says here is the updated code. Ideally, we should check the code, but let me copy this code blindly and go to our IDE. Here, we'll check the code. I'm more comfortable with checking the code over here. Okay, so first of all, the file name has got changed since we mentioned that this is the updated file. So file name has got changed. Great. And then yeah, we are mainly interested in this change, the updated thing. Since we had appended this updated in the class name, so yeah, it got changed. So yeah, apart from that, it has also written if else part separately rather than like this that we had written in the previous coding file. So it has updated that as well. Not a major change, but yeah, this is a major change. We also need to check if the previous code that we had written is working fine or not. It is also possible it has changed this code, updated this code, and the previous code has got broken. So let's run it. And yeah, data frame is not quite formatted, so let's not print it. Let's write df simply over here, which is the data frame. Yeah, it is working fine even with the updated file. So we have the price, number of bedrooms, number of bathrooms, area, and the address over here. So yeah, it is working fine. Summing it up, previously we were working with the original file where we changed the structure of the file a little bit, and we were expecting AI, we were expecting ChatGPT or large language model to detect that change and update our code accordingly. And if we go to ChatGPT, what did we provide? No, we'll see over here. So we provided this script, and by the way, all the material that we'll be using in this stream, the coding files, the even the PPTs, even this prompt that we are using, everything is provided to you, and the link is available in the comment section. Okay. Um, so yeah, we are saying that we have a problem. We were scrapping the website that was working fine, but now the website structure got changed, and these are the before and after files. Have a look at the structure and write the updated code. Here is my previous code, and AI is working great over here. In just a few seconds, without any effort, it has updated the code for us. Now, um, I think part one is done. We are able to update the code by using large language model. I have also explained how you can create your own AI, your own artificial intelligence agent that will be specialized in predicting the change in the website structure. Moreover, here we have done a bit of manual work. You have to download the HTML structure before and after separately in order to write the updated code. Still, it is a great facility if you're not very much good at coding, if you're not a very much techy person, you can adapt this change. But if you want to go completely in an automated cycle, you can use the APIs of OpenAI or any other LLM. The APIs are also available. So all you have to do is you have to provide the old structure through the you have to write a code, a cycle, where you will see if in any field I'm getting NA or not available, just like this. If I'm getting NA anywhere, I have to trigger the API. So when you will trigger the API, you will ask API that again the same you'll use the same prompt that we have used. You'll ask the API to update this thing, and the API will get you the updated code, and updated code will be again it will be there in the cycle, and the whole thing will get automated, right? But yeah, that is a bit risky since AI is not 100% accurate at all. So that is a bit risky so far. Maybe wait for 2 to 3 years more when AI will grow up. AI is a kid, not a kid, but a bit more than a kid. When AI will become a bit more mature, then it will work better. Okay, so here we have this code. We are getting the price, and we are eliminating the dollar sign from the price. We are replacing it with simple string. We are eliminating the comma and the plus sign as well, and we are filling the missing values, although we don't have any missing value, but it is always better to follow the precautionary measure. So we are filling the missing values with 0, and then we are getting the price over here. We are getting we are doing the same treatment with the bedrooms as well. We are doing the same treatment with bathrooms, number of bathrooms, and with the area as well. And then we are converting all of these variables to numeric. We are using two numeric function to do that. So we'll run it, and yeah, here we go. It is working fine. So the whole data is converted to numerical. And now what will we do? Just a few lines of code. We have simply imported matplotlib, Seaborn, and we have created a correlation matrices where it will be clear which variable or which column has how much impact on the change of the other column, right? Like here we can see all the values are close to 1, which means, for example, price column and area column, they are 0.98 correlated to each other. The correlation coefficient is 0.98, which means if it is 1, it means with a change of price, the area is also changing in same dimension, right? If area is increasing, price is also increasing. If area is decreasing, price is also decreasing, right? But if the correlation is equal to or close to -1, then it is an inverse relationship. For example, then area will be increasing and price will be decreasing, which is not the case, and vice versa, right? And if the correlation is close to 0, then we can say that there is a random relation, or we can say that there is a no relation. But here we can see that the relation is quite strong. On a positive side, number of bedrooms and number of bathrooms are 0.93. They have the correlation coefficient equals to 0.93, which means that, yeah, if in any property there are more number of bedrooms, then it is expected there will be more number of bathrooms as well, and vice versa, right? And here we have some scatter plots, some histogram plots that are also available. And let me tell you, I have generated whole, you can say 95% of even this code by using LLM, by using artificial intelligence, by using ChatGPT, for example. Okay, which is very easy. And then if we come over here, we come to the prediction part, we come to the machine learning part. So what I'm doing, I'm actually using, since we are in a regression problem. Regression means where you have to predict a continuous variable. Here we want to predict price of the property, which is a continuous variable, right? If you want to predict, for example, if an email is spam or not, if it is a cat or dog, this is a classification problem where you have distinct values to predict. But right now we are working with continuous values. Price is going to be the continuous value. So here the type of machine learning, the type of artificial intelligence that will be used, it is called regression analysis. So for regression analysis, all the famous algorithms I am using over here, in order to know which algorithm is better on my particular data set. There is no thumb rule that this algorithm is the best that will work great for you. Algorithms, the AI algorithms, they always depend upon your data. So yeah, I'm gonna go with brute force. I'll use all the algorithms and I'll find out which one is best. So I'm using linear regression, Decision tree, SVR, nearest neighbors gradient boosting regression algorithm, and then I'm getting some matrices as well in order to evaluate which model is better, which AI is better. I'm using train test split, and finally I'm also having a random forest regressor as well. So here I'm saying from that data frame that we have over here, okay, from this data frame, we already have what? We have price, bedroom, number of bedrooms, number of bathrooms, area, and address. We're gonna get rid of address for now because it is not a numerical column. So based upon area, number of bathrooms, number of bedrooms, we are gonna predict the price of the property. Right now, goal is not to achieve the great precision, the great accuracy. Goal is just to create it, okay? But it will be a reasonable one, don't worry. So we are saying the number of bedrooms, number of bathrooms, and area is going to be the X. X means they are the features. And price is going to be the Y. Y means it is going to be the label. We want to predict it. Okay. We are filling the missing values not needed for our particular data, but again, it is always better to follow the precautionary measure. We are creating train test split. Okay. What is this train test split? Remember the story, the kids story, how the guardian was able to decide if kids learning is great or not, if kid is able to distinguish between cat and dog or not. First of all, the guardian trained these kids on some data, and then this guardian tested these kids on some unseen data. Same the case is here. We'll split this data into two teams, training team and testing team. On training team, we'll train this data. It is usually 80% of the data. On 80% of the data, we will train our model, and remaining 20% of the data will test our model. Okay. So here we have the models, and then we are simply training them by using fit method. We are making some predictions. We are calculating some matrices over here. And then we are simply going to output the results. So if you allow me to run it, it will take some time. So it says these are the model performances. Linear regression has this much mean square error and R2 score equals to 8.2. What are these matrices? Let's not go into this whole thing. But overall, the best model right now is SVR, or support vector regressor. So what will I do? I'll copy this, the best model, and I'll paste it over here, which is already there. Okay, fine. I don't have to do that. So what I'm going to do, I'm actually doing over here, I'm creating a very simple graphical user interface by using iWidgets in Python. And here we are taking input in number of bathrooms, number of bedrooms, and the area. And we want to predict by using these three variables. If you remember, during training, we used the same three variable as the features, and we wanted to predict price. Now again, we are taking input from the user in same three features, and now model will tell the price, right? These three features can be different, right? For example, here we have written two, number of bedrooms are 2, number of bathrooms are 2, area is 1000 square feet. Okay, let me run it. And if I run it, let me run this warning thing as well in order to get rid of the warnings. Ta-da. Yeah, perfect. So if there are two number of bedrooms, two number of bathrooms, 1000 square feet, then this much is going to be the expected price according to this data. Again, if you will change the data, the model will change its parameters. It may be different. Let's increase the number of bedrooms. Okay, remember this is the price. Let's increase the number of bedrooms to 10. Okay, number of bathroom to, let's say, 5. And let's keep the area same. Expectedly, price should increase because number of bedrooms and bathrooms are directly correlated with price. So if I check the price now, what's going on? Is it changed or not? Let me see. No, let me run it again. Let's see. Let's write 10 over here. Let's predict it. No, let me see what's going on. Oh, okay. There can be an issue in the algorithm as well. So let's change the algorithm. Previously, we were using support vector regressor. Let's use random forest now. Okay. Let's replace it. Very simple. All we have to do is we have to change the name of algorithm over here. Rest of the code will work fine if we will rerun it. Okay. So again, number of bedrooms are 2 and 2, and area is 1000 square feet. This is going to be the expected price. Let's increase the number of bedrooms to 5, number of bathrooms to 4, and keep the area same. So yeah, you see price got updated and the price hiked up. If we increase the area as well, let's double it. Then yeah, price again, it increased. And if we decrease it, let's say, how about 1 bedroom, 1 bathroom, and let's say 100 square feet. Is it possible? Can be a bedroom. Let's try it. Yeah, according to AI, this is going to be the price in California for this much of an apartment or this type of a living, right? So yeah, that's about it. Here we can say that yeah, we have answered our first question, how we can use LLM or how we can use ChatGPT or any AI agent in order to create our own adaptive to changes scraper. Okay. And if you want to create a whole automated cycle, I have theoretically explained it as well. Now, coming to the second problem, which is related to scaling. If we want to use these proxies at a commercial level, for example, we want to create such a model, such a business model where we want to scrap prices from e-commerce websites in order to know what is how is the competition going. We want to scrap prices from Amazon, from eBay, and a few other platforms in order to know how much my product should list, right? And in order to do that, you have to keep scrapping these pages. And if you will keep hitting these URLs, then as I mentioned, they will block your IP address and you will not be able to visit this website anymore. So what to do? Maybe you can get some IPs on rent. Yeah, you can. And that process is called proxy usage. So yeah, there are some free proxies available in the market that can slow down the whole processing, that can somehow compromise your data as well. But If you will use some professional proxy providers, if you will take their services, maybe it will work fine. How these proxies actually work? Um, Before that, I mean, we go into which proxies you should use. What is a proxy and how it actually works? So proxy is basically an intermediate server. You ask this proxy provider, hey, can I use your IP address so that I can hit XYZ website to get the data? And if they will block the IP, they will block your IP, not mine, right? So it is an intermediate server. Your request goes to this proxy server. This proxy server will hit this XYZ website. This XYZ website will give data to this proxy server, and this proxy server will get you this data back. If this IP will be blocked, then this will be the IP of the proxy provider, and they will immediately provide you a new IP for that. um, it takes care of your privacy because your IP is not exposed anymore. It takes care of the caching, and it also distributes the workload as well. For example, if you have tons of different requests, it will shuffle the whole workload in a way that all the requests will go in parallel. um, and if we don't use proxies, what will happen? Your IP will be directly exposed to the to XYZ website, and it will be very easy for them to block your IP. You have the risk of detection, rate limiting, and bans are there. Obviously, you can hit a particular website for a particular number of times, not more than that. And then resilience is also an issue. So, what to do with that? You can use NetNut. Great proxy providers. I'm personally using NetNut for some of my work as well. They provide you rotating residential proxies that you can use for, I mean, they provide you 85 million plus residential proxies. For example, they're rotating proxies. You will hit XYZ website from one IP address, and then for the next request, your IP address will get changed, so that there's no chance that they can catch you. They provide you the mobile IPs, they provide you data center proxies, they provide you static residential proxies as well. So tons of different options are available. Very easy to use. Let me show you how to do that. So I think I'm already signed up on this page. Let me see. Yeah, let me log out. Okay. So this is how their page would look like. All you have to do is you have to go to netnet.io, and very easy process to create an account. Once you create the account, you will log in, and you will see they provide you the facility of using multiple languages. All you have to do is you have to click over here. Let me close this pop-up. You can use PHP, Python, Ruby, C Sharp, Node.js, Bash, Golang, and so on and so forth. You can also choose which kind of proxy do you want. Do you want data center? Do you want rotating or static proxy? Right now, I think I have only facility of US and India, but you can get proxy of almost any country from NetNut. So for example, by choosing all these variables, I'm working, let's say with Python, I need to work with, let's say, Google. I'll hit on generate. So once I will hit on generate, it will ask me for the password. I'll enter the password over here. And here you can see it has provided me the whole code that I can simply copy and paste over there on my coding environment, and this particular website will be scrapped. Very easy to use, very convenient to use, and very safe to use. So yeah, my personal recommendation goes with NetNut. Yeah, that's about it. That's about it. I really hope you guys have learned something, at least something from this session. The goal was to introduce artificial intelligence to guys or girls who are web scraping. The goal was to let you know where the web scraping industry is going with the invention, with the introduction of AI, and how much workload can you give to AI, how much workload can AI take from you. And yeah, that can also answer the question, where are the jobs of web scraping, where the web scraping jobs are going after the introduction or invention of AI. This is me, Zia.